All right, guys. So this particular unit, I'll be doing the examples at the end of the notes page. You guys can fill in the blanks of the questions prior to this by using the lecture and looking through the book at the pages that they're talking about. So you won't see the entire set of notes except for things like this, like how is this chapter different? Well, chapter 7, if you guys remember, chapter 7, we'll just kind of base it on the candy machine. We had this candy machine, and we said that P was equal to 0.42, let's say. And then we took a bunch of samples, and then we put all these samples in, and then we ran a simulations, and then we ended up with a p hat of, let's say, equal to 0.43. Okay, so we in the last chapter, excuse me, in the last chapter, we knew that the population proportion was 0.42, and we knew that our sampling distribution of p hat should have been pretty close to 0.42. So that is in like utopia and not even in the real world. Normally, we don't know this. So we have this unknown population, and we take all these samples, sample one, sample number one, sample number two, sample number three, and we put them on our dot plot all over the place, and we create this dot plot, and we say, oh, well, p hat is close to p. So p hat is equal to 0.43. So therefore, p is got to be 0.43. Okay, or pretty close to 0.43. So, man, this is when we start to get real because we never know the population. So now in chapter 8, we are estimating without knowledge of the population. Okay, so that's the big difference. That's the biggest difference you guys are going to see here. All right, so let's move down to the example, and then we'll tackle that. Oops, one. I'm going to change the font size, I think, if I can. Let's see. Let's see if I can do that. Here we go. Let's change the font size a little bit, and I want to see if I can space this out. I don't want to mess around with it too much. Let's try one more. Nope. All right, let's just be done with that right now. Okay, so let's do it this way then. I want to space some things out for you guys because I'm going to talk about using this example here. Oops. All right. Don't know why. That's a little messed up. The formatting is messed up, guys, so sorry about that. Okay, so let's. Will this let me do it? No. Well. All right, so let's kind of look at this here. So if we're looking at this here, a lot of stuff going on, a lot of new terminology. So if we're looking at a 95% confidence interval, okay, so the idea of a confidence interval is this. The confidence interval, or CI, contains all plausible, in other words, ones that make sense, plausible values of P. Okay. So a confidence interval contains all the values of P, the true proportion. Remember, This is the true proportion P. But as we talked about in chapter 8, we don't know what this is. This is a complete mystery to us, okay? So we're going to find an interval, meaning it has a beginning and an end that has all the possible values that it could be. Not necessarily going to be exact, but it could be, okay? So we use multiple different things. Confidence levels, confidence intervals. So this is our confidence level. This is our confidence level here. And that is just our success rate of all confident intervals. So we're saying that 95% of the time we're going to get successful confident intervals that have the true proportion of Americans in between the two. Okay. So we've got a couple of things going on here. So we're just talking about the idea of Barack Obama. It's an old one, but we'll just go ahead and go with it. So there's a couple of things we got to look at here. So let's just look at this piece right here. They give us the confidence interval right here. So let's go back to draw here. Let's change my color. So they give us the confidence interval. This confidence interval has a 0.44 right here. So that 0.44 has two things attached to it. It has a 0.03 negative, and it has a positive 0.03. And then on this end, it is going to have a 0.41, and this end, it's going to have a 0.47. Okay? So when you're looking at this, the 0.03 is the margin of error. So this is called the margin of error. And basically, this accounts for sample variability. Okay, so basically, remember on the last unit, we would sample something and we get 0.48. And then we'd sample something and we get 0.45. And then we'd sample something and we get 0.46. So this sample margin of error accounts for the sample variability. So we have this idea of a margin of error, and then we have this piece right here in the center. This is what is called our point estimate. This is our best guess. And remember, this best guess would have come from some sort of a sample distribution where p hat would have been equal to 0.44. And then our area in between here is 0.95. Okay, and this would be 0.41, and this would be 0.47, just to give you a visual. Okay, so that's our idea behind a confidence interval, is that we have our point estimate, which is our best guess, and then depending on what kind of confidence level we want, 95%, this is 95%. So just so you know, 95% is 2 standard deviations. So we've got 2 standard deviations this way, minus 2 standard deviations, and we have positive 2 standard deviations this way. So we have our best guess. We have our margin of error to account for variability. That tells us our best guess is in the center, but it may be to the left and it may be to the right. Okay. And so the idea behind these is that you have this point estimate, but the true proportion, and I'll put this one in green here, the true proportion P may be right here. Okay? It may be there. Or it may be over here. We don't know. We don't know where it's at. These are all question marks. Or it could be right here. We're not sure. But we do know 95% of the time it will be in between 0.41 and 0.47. Okay, so that's the idea of a point estimate. We are estimating where the actual proportion P will be. So let's interpret those things real quick. And so we're going to interpret a confidence level here. So I am going to give you a template here. I should have typed it out, but that's okay. I'm going to give you a template, and it's going to say we are, I'm going to put a blank right there, confident that the interval from blank to blank captures the true proportion of blank. That's our template here, okay? And so then what we're going to do is we're just going to take the information from above and add it to it. So we're going to go, oops, let me change this color again. Let's change it back to red here. Okay, so we're going to take this template and we're going to say, oh, we are 95% confident, 95% confident that the interval from 0.41 to 0.47 captures the true proportion P of what? Of Americans, Americans who approve of Obama's job performance. Okay, so the stuff in red is just context. Okay, so now let's go ahead and interpret. Let's go change our colors now again. Let's go back and interpret the confidence level. So our confidence level says this. So our confidence level in blank of all possible samples of the same size the resulting confidence interval will contain will contain or would capture, we'll just say would capture the true, well, and I'm going to put this as a blank here. And it would say would capture the true proportion. This would be, let me change it to red. So this would say 95%, and this would say the true proportion of Americans who approve of Obama's job performance. Okay. So that's the idea. So here's our template. So make sure you write this template down, this one here and this one here. And basic idea for this particular unit is that we have a point estimate. We have a margin of error on each side accounting for sampling. And then this confidence interval will tell us where the true proportion P may be based on that idea of a sampling distribution of a sample statistic. And so the area under the curve would be 95%. All right, guys, good luck. We'll talk to you later.